Hello students, welcome to Vinay Achali online videos. A polynomial is an algebraic expression of the form, p of x equals to a0 plus a1x plus a2x square plus a3x cube and so on, right? In which, a very important thing, in which the variables involved have only non-negative integral exponents. I repeat, the variables involved, this like this one, only non-negative positive integral exponents. These numbers should be integers and they should be also positive. Then it is called as a polynomial in x of degree n. I hope so you got it. Now you can see here that in this polynomial, the highest degree of x is 1. So it is a degree of the polynomial is 1 and it is called as linear polynomial. A polynomial of degree 1 is called as linear polynomial. Right here also you can see the highest degree of variable x is 1. That's why it is a linear polynomial. In next case, you see the highest power of the polynomial is 2. Right? X is also there, but highest power is 2. That's why degree becomes 2 and we get quadratic polynomial. It is a quadratic polynomial. A polynomial of degree 2 is called as quadratic polynomial. In this case also, it is called as quadratic polynomial. Now in this case, the highest power of x is 3. That's why it is called as cubic polynomial. So we got the point that a linear polynomial has at most 1 0. Right? At most only one factor are there. Means x will have only one value. A quadratic polynomial has at most 2 zeros. Means x will have two values in this case. And in the cubic polynomial has at most ज़्यादा में ज़्यादा 3 zeros हो सकते हैं. I hope so you got this point. Right. Then there comes the topic relationship between zeros and coefficients of a polynomial. Right. Zeros and coefficients for quadratic polynomial, we are mostly interested in this only. That is quadratic polynomial. Right. Means a polynomial of degree 2. Alpha plus beta means what here? Let alpha and beta are the zeros, means let it be roots of the required quadrilateral. Now here we have, I am just writing it again, ax square plus bx plus c. So suppose x and value are alpha and beta. So sum of roots should be this coefficient of x upon minus, I repeat, minus b upon a, and product of roots is equals to c upon a. That is, sum of roots is nothing but minus coefficient of x upon coefficient of x square, and product of roots is nothing but constant upon coefficient of x square. This should not be forgotten. Also, if you want to form a quadratic equation, then we had discussed already in a class that short form is x square minus sx plus p equal to 0. S means sum of roots, p means product of roots. Sum of roots means alpha plus beta, product of roots means alpha beta. I hope so you got this point. Right. And our next point is, you may refer this as for your competitive exams. There are also in the last optional exercises, there are difficult questions. There are also questions based on this, that is cubic polynomial, right? So its standard form of cubic polynomial is this: ax cube plus bx square plus cx plus d. If you are going to ask the sum of roots, the formula is minus b upon a. It is good to remember these formulas because we don't know what is going to be asked. It is from the textbook, so it is better we should learn it. And product of roots will be minus d upon a, alpha beta plus beta gamma plus gamma alpha equal to c upon a. So you should have to remember these three formulas about the polynomial. So that's what we had seen about what concepts in the polynomials, right? In the next class we will see how to find the various exercises, right? Zeros of a polynomial. It is very simple to find the zeros of a polynomial. For example, we will just take one example today. Suppose we want to find the zeros of the quadratic polynomial and verify the relationship between the zeros. So suppose for our polynomial is x square minus 2x minus 8, right? So we have what we have? We have the polynomial is, what is our polynomial? X square minus 2x minus 8. Now we have to factorize this. So we have to find the two numbers whose product is minus 8. Product is minus 8 and sum is minus 2. Sum is minus 2. So which are the such numbers whose product is minus 8 and sum is minus 2? Yes. So such number is 2 and minus 4, because 2 into minus 4 is minus 8 and 2 minus 4 is minus 2, right? So we will write this expansion here. So we will get x square, right? So our number was, what were our factors? 2 and minus 4. So we will write plus 2x minus 4x. 2 minus 4 is minus 2. If suppose we have written 4x minus 2x, it would have plus 2x. That's why we should write this as 2x minus 4x and minus 8. Now we will take x common, you get x plus 2, then we get minus 4 common. Remember here to take minus sign common, so we get x plus 2. Now we will get take x plus 2 common, so we get x minus 4. So these are the factors. Now to be 0 of a polynomial, we have to equate it with 0. So for px equals to 0, for p of x equals to 0, we have what we have. So x plus 4 into x plus 2 equals to 0. So in this, only cases possible are either x plus 4 equal to 0 or x plus 2 equals to 0. So we get x equals to minus 4 and x equals to minus 2. So these are nothing but what? So x equals to in this case we get, I will just check it down. It is right, x minus 4 is there. We have to correct it. It is x minus 4. Right. So it should be x equals to 4 and x equals to minus 4. These are the two zeros of a given polynomials. I hope so you got this point. Now sum of zeros. Now suppose you want to find the sum of zeros. I will just write it here. Sum of zeros. Sum of zeros will be nothing but equal to minus b upon a. Right. So minus b upon a is, what is b here? Minus 2. Right. Upon a. A is plus 1. See here. This equation. If we compare it with ax square plus bx plus c, so here we get a equals to 1 and b equals to minus 2, right, and c equals to minus 8. So we get what? Sum of zeros equals to minus b upon a, and that is equals to 2. And similarly you can find the product of zeros, that you get minus 8. So which you have to verify it, whether the relation is verified or correct is not. If you get a correct, then it is your zeros are verified for the given equation. In detail we will discuss this concept in the next video. Till then, bye everybody.